Hello world. In this one, we're going to talk about bash and short-circuiting and why its seemingly inverted behavior is a better design. So, what is short-circuiting? It's a phenomenon where the evaluation of a Boolean expression is cut short due to its nature. Before jumping into bash, let's look at some Python. 1 or 1 over 0. Do you think this expression is going to raise an error? Because the right operand results in 1. If you don't, then you probably understand short-circuiting. It will not result in an error as the left operand is a truthy value. And OR needs just one of its operands to be true, and the fact that the evaluation happens from left to right, the interpreter doesn't even need to look at the other side. It got a truthy value. No matter what the other side is, it will be true, because OR. So it doesn't evaluate the other side, hence no error. Now, if I do 0 or 1 over 0, it will result in an error because the interpreter has to see what the other side is to complete the evaluation. We can see the same thing happening in case of AND. 0 and 1 divided by 0 will not result in an error because if any one of AND's operands is 0, we don't need to look at the other one. It's just false. But 1 and 1 over 0 will result in an error. Let's look at a scenario in bash. I have a hello world in C. In a single command, I can compile to get the executable, and only if it's successful, run the newly generated executable. I have deliberately made a syntax error to show you that the executable is not going to be run when the compilation fails. Here's the error you get when you try to run an executable which doesn't exist yet. With the combined command, we're only going to see the compilation error because of short-circuiting. If you look at the behavior of the AND in case of Python, the right side doesn't need to be evaluated if the left one is false, or fails in this case. A command failure is falsy, and a command success is truthy. So, if the first command fails, the second doesn't need to run when combined with an AND. Look what happens if I use an OR, although it doesn't make sense in this case. We know the compilation command is going to fail, so bash needs to run the other command to complete its evaluation. Hence we see both the compilation error and the inexistent file error. Let's fix the error and run the command. As you'll see, the first command, compilation, succeeds, so bash should run the other command and will, and we see the hello world. If I make an error again, and then run the command, it will not execute the right command, but stop when the compilation command fails. If it would have, we'd have seen the hello world, as the executable is already there. So that was short-circuiting. Now, for the tricky bit. I'm going to write a bash function whose entire job is to return a 1, and another to return a 0. Will 0 or echo high print a high? If you consider 0 to be a falsy value, like in Python, it should execute the command on the right and print the high. But it doesn't. What about 1 and echo by? Will this print a by? With the same idea, 1 as a truthy value, it should execute the command on the right and print the by. Again, it doesn't do it. Well, it's because of the fact that bash treats 0 as a success and any non-zero value as a failure. And that's why you typically see that at the end of main, a 0 is returned to indicate that the program completed successfully. Just for completeness, you can see that 1 or echo by does print the by, and so will 0 and echo high print the high. Why this flippy behavior? Why is 0 a success? It's a little counterintuitive, but actually a wonderful decision, because error codes. Simply put, a program can succeed in one way, but fail in a lot of ways. And we need a way to report the kind of failure that occurred. Somebody killed the program, or the program wasn't passed the required number of arguments, and so on. We need more info on the error than on the success. So, multiple non-zero values for failure and a singular value for success. And that was all for this one. Thanks for watching.